The objective is to establish reliability, validity, and norms. Now, in the final tryout, you have to take a large sample, maybe approximately, I don't know how much I should write, maybe 500, maybe 600, depending upon the size of the population. If you want to take more than that, then that's okay. But important point is that in this one, you cannot have the data of the people whom you have, which you have already used in item analysis. So this 600 must be the fresh. And if it is the fresh, they will belong to the different institution. They will be gender and things of that variety, you know it. Now let us see how do we establish the reliability. So I'm telling you methods of reliability. Now, one of the method of reliability is test, retest method. What is the meaning? The meaning is that whatever the tool for which you want to establish the reliability, you administer that tool on the 600 people, say, on a particular day. Now, then you do the scoring, and that will be the scoring for the test. Now, this retest must be taken after the gap of some days. Now, how to decide the gap? The gap between test and retest is to be gap between test and retest is to be decided whether the variable under study can change. So the gap between test and retest should be such so that there is no change. So that there is no change in the variable for which the tool is used. For example, if you are developing the tool for the reasoning, now you have to decide whether the reasoning can change at its own within 10 days, 15 days, 20 days or so. Normally, the time gap between test and the retest people have been taking as 10 days or 15 days, and some of have taken even 1.5 months. But the more the time gap between test and retest, the commonness decreases, and therefore the reliability also decreases. So you have to decide the time gap between the test and the retest. And after that, now you can have the scores of the test and the scores of the retest of the same people. Say this is your serial number and this is your test score and this is your retest scores. And this is your test scores. Now here is the student number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like this. You have taken 600, so you have to administer it on 600, taking from different institutes. And in some of the places, you administer it in the morning session, and in some you administer in the evening session. And then you can do the scoring. So you will be having the scores here. So you will be having the scores here. Now, whatever the gap you have decided, after that particular gap, administer the same tool on the same people. You cannot take another group. And when you are re-administering, then it is quite possible that some of the people might be present in the first testing, but they might not be present in the retest. Suppose one was present in the retest, so you have second also present, third also present. Suppose this was absent. Say he was present, 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 present. Say this is absent. So some of the people might be absent on the retest. And when they are absent on the retest, their retest scores should not be considered. So the test scores of number 4 should not be considered. So you can delete it, and the score of 11 also should not be considered. So you only have to consider the scores of those people who were present in both the testing. And now you compute, calculate the correlation between test and retest scores. And if your correlation value is greater than 0.5, the higher the value of the correlation, the higher will be the reliability of the tool. Now it is very clear to you that here you are administering the same tool on the same people at 2 points of time. If your tool is assessing the reasoning, then you are assessing the reasoning of each individual twice to start with, and after the gap of 15 or 20, whatever the days that you decide. So therefore, you will be having the reliability for the test and the retest for that particular variable. So you are finding the correlation of reasoning with reasoning. And if it is a self-confidence, you are finding the correlation of self-confidence with self-confidence. I hope you are understanding. So therefore, the correlation, reliability coefficient will always be positive. So the correlation will be positive. I'm in the webinar. So the correlation will always be positive. Because you are finding the correlation of the variable with itself. So it cannot be negative. So this is the point that you should understand. Now in test retest, reliability in reality, you have not to bother about anything. You have not to bother about the number of the items. You have not to bother about the difficulty level, the discrimination index, etc., etc. Because you are administering the same tool on the same people again. Now, then there is another one, and that is split half. Split half reliability, or you can also call it odd even method. You can call it split half reliability method, or you can call it odd and even method. Why? As the name suggests, your tool must be divided into two equal parts. The items of the tool should be divided into two equal parts. Now, if you decide to use this particular method, then dear friends, it is very important for you that you should have two items which will have the same difficulty level, same discrimination index. They must belong to the same aspect, must have the same weightages. And then you can keep one on one side and another on another side. So your first item and the second item must be equivalent. Your third and fourth item must be equivalent. So like this, so that you can split it by taking all the odd items on one side and even items on another side. So what you can do is, you can do something like this. That suppose here is a serial number And here is your item 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and like this. So if there were, let's say, 30 items, so you have the 31. Now this is your first person, the second, third, fourth, fifth, sixth, seventh, eighth, 9, 10. And this is your 600. In the split half reliability, you only have to administer your tool once. You should not administer it twice. Only once you have to administer. Whereas in case of test retest, you were to administer it twice. So if you have taken 600 people, then you have to have the copies of the tool as something like 1200 or something like 12, more than 1200, maybe 1220 or 1230. But in split half, you only have to administer once. So you are saving a lot of time and you are saving the money also. Because here you only have to collect the data from 600 people by administering it only once. But in the split half, you cannot use it if you do not have the two parallel form type of thing. So therefore, what you can do is that you can put the score of the people here. And you can find out the total here. You can find out the total score of the person. Now, for the second person, the score on each item, and then you can find out the total score So now if you add the score on item number 1, on item number 3, on item number 5, on item number 7, on item number 9. So these will be, and so on and so forth. You will get the total marks obtained by each person on odd items. So you will have the score of the people on odd items. And if you subtract the total of the odd items from the total, you will get the score of the even items. If your odd item score is 40 and your total is 80, so your even will become 40. Or if your total is 60, then it will become the 30. So like this you can find out. So you can find out the score on the odd items and the scores on the even items. And now you have the scores here. You have the scores here. You have the scores here. You have the scores on each odd items as well as the even items. And now what can you do is you can now find out the correlation. Now, because your total score, total items were 30, so here the odd items will be 15. And even items will also be 15. So this also will be 15. So therefore, now what you can do is, you can find out the correlation between the odd items and the even items. And if you find the correlation between odd and even, then this will be R half and half. That means you are finding out the correlation between half of the tool with the half of the tool. And suppose this correlation comes out to be 0.6. Now you have to find out the correlation for the whole tool. You do not want correlation only for the half tool. So in order to find out the correlation for the whole tool, you have to use Spearman-Brown formula. So Spearman and Brown were the two people who gave this particular formula for computing the correlation for the whole tool. And it is R11. And this will be equal to the formula which they gave was that you have to multiply R half and half by 2. Why? Because if you multiply half by 2, it is the 1. So therefore, this is the 1, that's what you have to have. And you have to divide it by the 1 plus R half and half. Why plus? You can think and I will tell you. Now here, because R half and half, I told you is 0.6. So that means this will be 0.6. 0.6 is to be multiplied by 2. And then this has to be divided by 1 plus 0.6. So if you just solve it, you will find that 0.6 multiplied by 2 is 1.2, and 1 plus 0.6 will be 1.6. And if you solve it, it will be 0.75. So 0.75 becomes the split half reliability coefficient. And you cannot have it minus. If it is minus, then the correlation will be more than 1. You can see if I put it minus, 1 minus 0.6 means 0.4. And 1.2 divided by 0.4 means 3. And the correlation value cannot exceed 1. So therefore, they use the logic in order to come out with this particular formula, the Spearman-Brown formula. Now, this particular method will be quite all right, provided you have the even number of items. Because if you do not have even number of items, then when you split into 2 parts, then in one part you will have more items and another part you will have less items. But items must be equal in number. But if you have odd number of items, then test-retest reliability method will be quite appropriate, because it doesn't require the number of the items to be in the even number. Now, in the split half, you must know that the items which will be in the one part of it and the items in another part of it, if it is a test, then they must have the same difficulty level, the same discrimination index, the item must be of the same type, the scoring must be the same, etc., etc. If it is a scale, then you must have the equal number of positive and negative on both the sides. So these are some of the problems when you want to establish the reliability with the help of split half reliability method. Now, any question you want to ask, then I proceed further. Any question any one of you want to ask? Then another method is called parallel form, or you can say alternative form, or you can say equivalent form. Now, from this particular name, I'm sure you have understood that you have to have the 2 forms of the same tool. And when you have the 2 forms of the same tool, if or in one form, if you want to have 30 items, then in second form also you have to have 30 items. If you are developing a scale, then the number of positive and negative items in both the forms must be the same. If it is a test, then the items must be equivalent with respect to the difficulty level, discrimination index, content, cover, and the type of the item. Now, the point you have to understand is that if you want to use this particular as a method for establishing the reliability, then right in the beginning, if you want to have 30 items in one particular one, so you have to have 60. But if you want to have the parallel form, then you should have 120 items to start with. So double, because 30 in one and 30 in another, and you have to have more. So therefore, you have to write more number of the items. And many a times it becomes very difficult to write items which are having the same difficulty level or discrimination index. So depending upon your requirement, you can see whether you should go for parallel form or not. Now you can ask me a question, where do we use? See, if suppose you want to administer the tool for selecting the people for the job. Now, for example, the exam which is being conducted by the CAT to take admission in IIMs. Now the CAT exam continues for many days together. And if it continues for many days together, the number of items must be the same. That each time a candidate is supposed to solve, say for example, 30 items, then each day the candidates will be solving 30 items. But the 30 items which the candidates got on the first day will not be there on the second day. So they have a large bank of the items, and these items must be parallel. If they are not parallel, then sometime the candidates may get the simple items, or sometime they may get difficult items. And then people will go to the court and there will be litigation. So therefore, it is important that when you want to have the test which you want to use for selection purpose, then parallel form method is the most appropriate method for establishing the reliability. Now, how do we do? Suppose now you have form A and you have form B. If you have taken 600 people, then you have to administer form A on all 600 people and form B also on all 600 people. If you are administering form A, say tomorrow morning, then tomorrow morning only, if possible, after a gap of maybe 1 hour or 1.5 hours or 2 hours, you again give them the form B. The same candidate should be given the form B. If it is not possible, then if you administer form A today in one particular institute, then next day morning, you should come to the same institute and administer form B. That means the time difference between the administration of form A and form B can be at the most 24 hours, but it should not be more than that. Now, then you have to administer both in the morning and in the evening session, and then you will have the scores. You can find out the scores of each person on the form A and also on the form B. And if you have the 600, then you will have the 600 scores for form A and 600 scores for form B. And now you can find out the correlation. The correlation value should be more than 0.5. If it is not more than 0.5, then your tool is not reliable, or your tool has weak reliability. But if it is more than 0.5, then your tool has got the high reliability. So your split half methods and parallel form methods, they are very different than your test retest. And now you see that in a split half, you require only the even number of items, and in parallel form, you require double the number. If you want 30, you should have 60 items. You should select 60 through the procedure which I have already explained. So I hope you have understood these 2 points very clearly. And you should know when to use the test retest, when to use the split half, and when to use the parallel form. But for selection purpose, it is the parallel form tool will be more useful, and people do have the test which they want to use for selection purpose, and for that they have the parallel form method. Now, any question you want to ask up to here? Any question you want to ask? I'm waiting for your answer. Now your test retest, split half, and the parallel form method you can use for test, for scale, as well as for inventory. Now I am going to tell you another one, and this you cannot use for the scale and inventory. You only have to use for the test, and that is Kudder, Richardson, Richardson formula 20. Now this formula you can use only and only if you want to administer, if you want to Dr. Petro, did you join late? Just now I explained. Please know. I request you, Petro, I will explain, but please join on time. When I can leave my very important work just to be with you people. See, the test retest reliability method you can use, no problem, whether your number of items are same or number of items are different. It does not make a difference. But only the point is you have to administer the same tool on the same people twice. The gap between test and retest, you have to decide whether you want 10 days, 15 days, 20 days, 1 month, 1.5 months, 2 months, whatever it is. So that has to be decided by you as a researcher, and it will be decided taking into consideration the nature of the variable for which you are developing the tool. Whether that variable can undergo a change during the gap period. And if it can go under some change, then you should reduce the gap. And then you can find out the correlation between the test and the retest. If you are trying to find out the reliability of reasoning test, then in that test you have the scores of the reasoning. In the retest also you have the scores of the reasoning. So you are finding the correlation between reasoning and reasoning. So it will always be positive. And your correlation value should be greater than 0.5. If it is more than 0.5, it will be more reliable. If it is less than 0.5, it is less reliable. Now, there is another method, split half. As the name suggests, that you have to split the tool in two parts, two equal parts. If you have a scale, you should have positive number of items and negative number of items in both the parts of equal. If you have 5 positive, then in another part also 5 positive. If 3 negative in one part, in another part also should be 3 negative. If it is a test, then you can divide it on the basis of the difficulty level, discrimination index, type of item, etc. And you have to administer this on 600 people only once. And then you can make the table like this, do the scoring, and your item number 1 and item number 2 are parallel. Item number 3 and item number 4 are parallel. Item 5 and item 6 are parallel. Now you can add the score on item 1, 3, 5, 7, 9, 11, 13, etc. And that will be the total score on odd items. And you have this grand total. From grand total, if you subtract the total of the odd scores, you will get the total of the even. So we'll get the total of the odd scores and total of the even scores. And you find out the correlation. Now there were 30 items. So you have divided into 2 parts. So there will be 50 items in each. So this is the correlation, not of the whole tool, but only of the part of the tool. But you want to find out the correlation, the reliability coefficient for the whole tool. Now, then you have to use the Spearman-Brown formula to compute the reliability for the whole tool. And this is the formula, that R11 is equal to 2 multiplied by R half and half divided by 1 plus R half and half. Your R half and half value is 0.6. So multiplied by 2, it is 1.2. And it is 1 plus 0.6, it is 1.6. And if you do it calculation, it is 0.75. So this becomes your reliability. And the third one is a parallel for method. I told you, if you want to have this, then if you want 30 items in one, then you have to select 60 items, because you are having a parallel form. So you have form A with, say, 30 items, in the form B also 30 items. So they are parallel in all respects. If it is a scale, it's parallel in terms of the positive, negative items, in terms of the dimensions. If it is a test, these are parallel in terms of difficulty level, discrimination index, etc., type of item, etc. And then you administer both the forms on all people, and then you will have the total score of the people on form A and form B, and now find out the correlation, and that your correlation, if greater than 0.5, then it means your tool is reliable. And now you get two tools, Form A and Form B, and both are reliable, so you can use any one you like. Now another is Kudar-Richardson formula 20. Now this can be used only in case of test having objective type items. Why? Because if your items are not objective type, if it is essay type, then you cannot say whether your answer is completely correct or completely incorrect. So therefore, it is not possible. But you cannot find out the reliability using Kudar-Richardson formula for those test items where you cannot say whether the answer is correct or incorrect. So that is why the Kudar-Richardson formula 20 can be used only and only for the test, because in case of a test, your answer can be correct or incorrect. But in case of scale and inventory, your answer cannot be incorrect because there is no fixed answer. So that is the point that you should understand. And here you should have objective type question, multiple choice, fill in the blanks, whatever you want to have it. Now, the formula 20 you use when your test contains items with different difficulty level and the discrimination index. But if your difficulty level of all the items is the same, then you use Kudar-Richardson formula 21. But for all purposes, it is the 20 that is to be used, because our items cannot be having the same difficulty level, they will have different difficulty levels. So now what we have to do is, we have to administer this particular tool on a set of people. You have taken 600, so you administer it on the 600 people. Perfectly correct. And after administering it, so in some of the institute, you go in the morning, in some of the institute, you go in the evening. Okay, and therefore you will be having the scores. And after you get the score, you can tabulate it something like this. Let me just try to make some space. So you have here the serial number, and you have your item 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And suppose if you have total item as 30. and then you can find out the total here. Now this is your one subject, another. So you have your 600. Now you see the first person out of 30, how many items where he has given the correct answer. Say he has given the correct here, and here he has given the correct. Here he has given the wrong. Here he has given the correct. Here he has given the correct. Here correct. Here correct. Here he has given the wrong answer. Correct answer, correct answer, correct answer. And then you can find out the total score here. Now the another person, he has given the wrong answer. He has given correct, 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 correct. He has given wrong here, and he has given wrong here. He has given correct answer here, correct answer, correct answer. So you can find out the total score here. So now what you can do is that you can count, and you can find out that how many people have given the correct answer. So you find out P. P means proportion of the correct answer. P is equal to proportion of the correct answer. And then you find out the Q. Q means proportion of the wrong answer. And if you find out the P and Q, it must be equal to 1, because it is proportion. So if suppose out of 600, the first question is attempted correctly by 300 people. So here it is 0.5. Okay. Now another question. Say another question is attempted by 500 people correctly. So 500 divided by 600, and this will be 0.83. So it is 0.83. Now, suppose that here the let us say 200 people have given the correct answer out of 600. So this will be equal to 0.33. So like this, you may have here 0.4, somewhere you may have 0.2, somewhere you may have 0.3, somewhere you may have 0.9, like this. And then you can find out Q. Q means this will be 0.5. So this will be 0.5. And this is 0.83. So 1 minus 0.83 means 0.17. This is 0.6. So this is 0.66 or 0.67. This will be 0.6. This will be 0.8. This will be 0.7. This will be 0.1. And now you can find out the product of P and Q. So this will be 0.25. Now this you can multiply 0.83. It is 0.83 multiplied by 0.17, and this will be 0.14. Now 0.33 multiplied by 0.67, and this will be 0.22. And this will be 0.24. So you can keep on finding out. This will be 0.16. And then you can find out the summation . So you can find out the summation of PQ. You can add 0.25, 0.14, 0.22, 0.24, 0.16. You add everything. That comes to sigma PQ. Now what you have is here. That now you have the sigma PQ . So that total you know. And now from the total score, you know these total score. And from total score, you can find out the standard deviation. And this will be the standard deviation for the whole score. So you can find out the standard deviation here. If you are representing standard deviation by sigma, then you will be having the sigma total. And you know the N. N means total number of the people. N is the total number of, or you can say the size of sample. Now, in this case, I have taken 600. So therefore, this is what information you have. Now you can find out the correlation, that is R11, or you can find out the KR20 value. Now this KR20, when you are finding out, then you should have I think I have here, please, there is a problem because when I write, it is n divided by n minus 1. And then this has to be multiplied by sigma total. And then you have minus sigma PQ. And this has to be divided by sigma total. So this is what exactly the formula, which is for the Kudor-Richardson formula 20. So you have to find out these values. And if this is more than 0.5, then of course it is high, otherwise it is low. So you can use this only and only in case of a test. This you cannot use for the scale. I hope you have understood it. So these are some of the methods of establishing the reliability. Now, as Kudor-Richardson formula 20 is a special case for the test, although for the studying the reliability of the test, you can use test retest, is split half and parallel form, no problem. But this is another one which you can use only for the test. Similarly, there is one particular method which you can use only for the scale. You cannot use for other than the scale. And that is now, it is called Cronbach alpha. See, Cronbach alpha method is to be used only for establishing reliability of scale. You cannot use it for test as well as for inventory. It is only and only for the scale. I hope you are understanding it. Now, in the scale, you will have the positive item as well as the negative items, and both must be equal in number. And you have arranged them in a random fashion. You have not arranged all positive one side and then negative. No, they are mixed. And you have to administer only once to the 600 subjects which you have taken for establishing the reliability. Now, in some case, you can administer it in the morning, and in some you can administer it in the evening, so that your tool can be used both in the evening as well as in the morning. So now what you have to do is, after you have administered it, then you can do the scoring. And now your score can be something like this. Let me now make some space for you. So what you do is, you have administered it only once, and you have done the scoring. And now you can enter the score something like this. Let me just stop sharing and I again share it. Now, here is your serial number. So here, this is your serial number. And this is your item 1, item 2, item 3, 4, 5, 6, 7, 8, 9, 10. And if there are 30 items, then you have the 30. And here will be the total. Now the first person, the second, the third, the fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12, and like this you have. So you have your 600 people. Now, this is the item number 1, because it is a scale. And if you have a 5-point scale, then your lowest score can be 1 and the highest score can be 5. So therefore, the score can range from 1 to 5. So the first person may have a score of 4, and another person may have a score of 2, maybe 3, maybe 1, maybe 4, maybe 5, maybe 2, maybe 3, maybe 4, 2, 2, 3, like this. Then this is the another one. You have the 3, 2, 2, 1, 4, 5, 2, 3, 1. So you have the scores like this. So for this also you have the score. So like this, you have the score for everyone. Now what you can do is that from this, you can add all these scores here and you will get the total score. And you will get the total score. Now from these total scores, you can find out the standard deviation. And therefore, you can find out the total standard deviation. So this total standard deviation from the scores. We have understood it. So these scores, you can add them here, and then you can find out. Now what you can do is for each score, you can find out the standard deviation here. So you can find out the standard deviation. And then you can add all these, and you can have you can have the total of standard deviation. And now you can use a formula. I'm giving you the formula. You know your total number. You know here your and you know your n. And mix the number of items. And then you can find out the value of the alpha. And for the alpha value, let me give you the formula. So now you can, this is the formula which you can use. You know, n, this is your, if you want, you can denote by small n, and you know your sigma total, and you know your sigma. So what you have to do is that this each is to be square. So you can find out the square of the standard deviation here, everywhere, and then you can find, add them up. So you know that, and this sigma is nothing but sigma total. So you can put your values here and you can find out the value of alpha. And your alpha should range. It can range between 0 and 1. But your value must be close to 1. If it is close to 0, then your reliability is low. And if it is near 1, then your reliability is high. So therefore, you know this thing that, so this alpha value will range from 0 to 1. Now, these are the different methods of establishing the reliability. Any question you want to ask before I proceed further? Now I am going to methods of validity. Now there is one method is called face validity. Many a times you look at the face of the people and you say, are you tired? The person may say, no, I'm not tired. But from your face, it looks that you are tired. So that means, and there is a song, चेहरे ने लाखों को लूटा, दिल सच्चा और चेहरा झूठा. So many a times what comes at the face may not be reality. Some of the people have such a face, smiling face. Even if they are having pain, still they will be smiling. But some of the people do not have a smiling face. Even when they are normal, still you look at them as they are very angry. So therefore, the face validity is one of the most useless validity. Please do not use it. Let me tell you, I read it in the newspaper that in the board exam, on the envelope, it was written mathematics, and it was a mathematics paper on that particular day. But when the envelope was opened, then they found that it contained the Hindi papers. So that means from the top, it is written mathematics paper, and inside you have a Hindi paper. So the face tells that it should have mathematics paper, but it doesn't have mathematics paper. This is face. So face validity is one of the useless validity. Now, many a times you purchase a book by reading the title. And many a times the title is very catchy. And your title may reflect that this particular book is about this. But when you go home and read, you may find, no, it's not about what the title reflects. Another example, there is one particular test. It is written problem solving test. But if you read the items belong to arithmetic problem solving. So from the title, it looks that it is for problem solving, but it is in reality arithmetic problem solving. So many times the title mislead you. So this is the useless method, and another is called content validity. I told you during the development of the tool, after writing the items, you have to give items to the experts. And each expert will evaluate the item and will say whether the item is to be rejected or it is not to be rejected. If it is not rejected, then it should be kept in the tool. Now, from the observation of the experts, now you can find out what you call it content validity ratio. It is called CVR. And the formula for computing CVR is that number of the experts who have said that the item is essential. Any means the number of the people, experts saying that the item is essential, then minus n divided by 2. And this whole is n divided by 2. So you should understand that any means number of experts agreeing that the item is essential. Item is essential means the item can assess what the tool or the researcher wants to assess. Now suppose, let us say that your NE is equal to suppose you have got the response from 12 people and all 12 people say that it is essential. So NE is equal to 12 and your N, capital N, is also equal to 12. So then CVR is equal to, it is 12 minus 12 divided by 2, then whole 12 divided by 2. So this will be equal to 12 minus 6, the whole divided by 6. And this will be equal to 6 divided by 6. So the value is 1. This can be your maximum value. Suppose there is an item where no one says it is essential. So suppose no one says it is essential. So NE is equal to 0. So then CVR is equal to that this is 0. Now that means it is 0 minus 6 and divided by 6. This will be equal to minus 6 divided by 6 will be equal to minus 1. So the CVR value can range between minus 1 and plus 1. So if your CVR value is more towards plus 1, it shows that the tool has a content validity because the judges agree. So more number of the judges agreeing means your CVR value will be positive. And your CVR value should be greater than 0.5. So this is how you can find out for each item the CVR. And this you should do even before you come to the item analysis. Because once you have the data from the experts, you can find out the content validity. So this is the one which you can always establish. It can be established for the test, for the scale, for the inventive, but cannot be for the schedule, in observation schedule, interview schedule, and questionnaire. You cannot. Okay. So therefore, these are the two methods I have explained you. More methods I'm going to explain you tomorrow. So please try to be on time, because tomorrow will be the last of this particular series. And after that, I will not have the webinar with all of you. So any question you want to ask, tomorrow you can ask me, no problem at all. And then I will tell you the other methods of validity. So any question you want to ask before I say bye-bye to you? Rawat, pilot study is not every time. There is no pilot study as far as the tool development is concerned. The pilot study means you want to do a miniature research in order to learn how to develop, how to administer the tool, and how to collect the data. If you are a novice person, and if you don't know how to collect the data, then you can do a pilot study. So in pilot study, you know whether the tool can be used or not, how they can be used, and how can you collect the data. So just to familiarize with the complete procedure, so you do a pilot study. Every time you have not to do the pilot study. This pilot study cannot be everywhere. Okay, if there is no question, then thank you very much. See you tomorrow.